Good morning, all of you. Today I am going to present my research work entitled Antibacterial Activity of Biologically Synthesized and Trima indica based iron nanoparticles. Next, Trima indica Roxburghi. Trima indica Roxburghi Joseph belongs to family Aspergillus, genus Tremia, species Indica, common name Indian Spiloranganda. Morphology of Trima indica is it is a bulbous herb, leaves are radical, a basal rootine disc is present in that particular plant. Medicinal properties of Tremia. Bulb of Tremia are stomachic, antihelminthic, curative, and laxatory. Medicinal uses. It is useful in paralysis, bronchitis, asthma, leprosy, rheumatism, renal calcul, leprosy, skin diseases, etc. It is also used in Indian traditional medicines. Biological synthesis of iron nanoparticles. First of all, material methods. Trema indica fresh leaves were collected from Deodarium berry satara. Chemicals required were purchased from Thomas Baker's Private Limited. Preparation of plant extract. Trema indica fresh leaves were taken and those were washed under tap water, washed with distilled water, dried at room temperature. Then 20 grams of leaves were taken into 100 ml distilled water. They were boiled on hot plate at 100 degrees centigrade for 15 minutes. That extract was filtered through Watman filter paper number 1. Then that was passed through Buckner's funnel and then stored and used for the nanoparticle synthesis. Synthesis of iron nanoparticles. We have followed the standard protocol for the synthesis of iron nanoparticles biologically. In burette, leaf extract was taken 20 ml of 20% stock. In conical flask, 3 millimolar FeSO4 solution was taken. Then leaf extract was added to 3 millimolar FeSO4 solution dropwisely with continuous stirring on magnetic stirrer. Colorless FeSO4 solution turns dark colored. It indicates the formation of iron nanoparticles. Those solution was the solution were centrifuged at 1000 rpm after 12 hours. Pellet washed with distilled water and oven dried. That pellet was powdered and stored for further analysis. Then antibacterial activity. Antibacterial activity was measured by microtactor broad dilution method. We have followed this standard protocol for this, and we have taken 4 human pathogenic bacteria for antibacterial activity. Results and discussion. Characterization of nanoparticles. First of all, we have characterized the nanoparticles by UV visible spectroscopy, X-ray diffraction, which is XRD, and scanning electron microscope, which is SEM. UV visible spectroscopy. In this particular graph, we can see that there is a peak out at 294 nanometers and clearly indicate that the formation of iron nanoparticles. Then X-ray diffraction, which is XRD, we can observe the physical property of that particular synthesized iron nanoparticles by this XRD. These peaks were compared with standard GC-PDF file of iron nanoparticles, and we have concluded that the synthesized nanoparticles are of iron nanoparticles. Then scanning electron microscope, which is SEM, it is this is a method for analyzing the size and shape of that particular synthesized iron nanoparticles. We can here observe that the synthesized nanoparticles were spherical in nature. They were agglomerated, and the size of nanoparticles were ranges between 50 to 80 nanometers in size. Then antibacterial activity of iron nanoparticles. For that, we have taken 4 human pathogenic bacteria. First was Pseudomonas aeruginosa, Klebsiella pneumoniae, Bacillus subtilis, and Escherichia coli. We have compared those nanoparticles with standard streptomycin. Here we can see that Pseudomonas shows 25 microliter per ml MIC value. Klebsiella pneumoniae shows 25 ml per ml MIC value. Bacillus subtilis shows 25 ml per ml MIC value, and for Escherichia coli, it shows 50 microliter per ml MIC value. MIC is nothing but a minimum inhibitory concentration of that particular iron nanoparticle. Here we can see that the percentage inhibition of bacterial species. In first graph, we can observe the percentage inhibition of bacterial species using antibiotic streptomycin. In another graph, we can see that percentage inhibition of bacterial species using iron nanoparticles. So here we can see that for Pseudomonas aeruginosa, And there is a highest percent inhibition at 51%. For Klebsiella pneumoniae, the highest percentage inhibition is 54%. For Bacillus subtilis, the highest percent inhibition is at 56%. For Escherichia coli, it shows the highest percentage inhibition of 51%. Bibliography, these are some references. Thank you.